MSAZ Talks is a monthly seminar series focused on bringing the tech community together to discuss the role of technology in society. We aim to bring together developers, researchers, and end users to discuss exciting topics at the forefront of technology innovation. All these talks are hosted by the MSCAC program, a world-class graduate program that provides employers with direct access to applied research talent. I'd now like to introduce our speaker. I'm very excited to introduce Parasvil Patel. Parasvil is a partner with Radical Ventures, where he collaborates with visionary entrepreneurs using AI to transform traditional industries. His talk today will cover the progression, successes, and the next wave of AI commercialization. Over to you, Parasvil.
Thank you, Arvind, and Philip, thanks for organizing it. Let me share my screen and get started. So as Arvind mentioned, I'm going to talk today about the next wave in commercializing AI research and what that means for all of us. We've talked about my bio briefly. I'm a partner at Radical Ventures. We are an early stage investment firm. We invest in startups all the way from 2 or 3 people who are starting a startup till about the Series B stage, primarily across US and Canada. And our focus is investing in AI startups. Our thesis is that AI is going to impact everything. It will certainly impact the way we use and interact with technology, but also in all the other fields out there, from healthcare to climate change. AI has the possibility of being a change for good. This is a sector that we've been investing in for a number of years, and that is where the context of this talk comes from. So as a team, we've invested in about 50 startups over the last 5 years. We see more than 2,000 startups in the category every year, spanning everything from those platforms that you saw in the previous slide to vertical applications. And that is what we're going to talk about, which is how has AI been commercialized? What are the trends that we are seeing, and what do we see as the future for commercialization? This is not a talk on research trends. Most people in the audience, as well as Arvind, would be better equipped to talk about that. I'm going to be focusing on primarily on commercialization. So with that, I'll probably spend the next 20 to 30 minutes going through about 15 slides. As Arvind said, if you have any questions, please drop it in the Q&A function. I would love to spend the remaining time of the session today actually going through the questions and having more of a discussion around some other themes that I cover here. So with that, let's go back in time to look at parallels from a different technology and the adoption of a different technology, and see what we can learn to the AI adoption that's happening right now. So I want to take us back to cloud computing, and even within the era of kind of the 80s and the early 90s, when on-prem servers were the primary kind of force. So everyone who wanted to have a software running for their enterprise will have their own servers. They'll have the system administrators kind of manage these servers. And it involved a heavy upfront cost for anyone who wanted to have access to computing available, either internally or even sometimes to deploy software. That started changing in the late 90s and early 2000s. A number of different technologies enabled that, starting with ASPs, VPN, virtualization. AWS actually started taking shape in the mid-2000s. Azure was launched around that time also. And what that did was, in addition to obviously getting us access to what we now know as cloud computing, it enabled new business models. And it enabled something called SaaS. It's a business model, it's a delivery model, and all of that was enabled through kind of the advent of cloud computing. Salesforce was one of the earliest adopter of this new business model. And we see that this has become kind of the de facto way of actually building a new application and serving the software out there. Right? So this is not something that is relegated to the cutting edge. And this has been driven primarily because of the ascent of hyperscalers. So I'm talking about AWS, Azure, GCP, et cetera, who make it really possible for anyone and everyone to put an application out there for everyone to use, whether it's a web app or even in the case of mobile applications. And this has become a default option for building software. It has significantly reduced barriers to entry from a cost perspective and an ease of use perspective. It has improved speed, reliability, the ability to scale a particular product and access. And it has led to cloud ops actually so important for how we build software now. So while the rest of the talk is going to focus on AI, I wanted to kind of take a look at this journey that happened over the about a 3-decade kind of time frame, and look at where we are now and kind of position us in a different point in time in the AI adoption curve, which I actually think is moving very similar to this cloud adoption curve. So let's start talking about AI. So AI commercialization, I believe, follows a very similar trend. Now, obviously, research in the large field of AI, and AI, I think of it as a superset, including kind of machine learning and deep learning as kind of participants in kind of that superset. Obviously, research has been going on for multiple decades, but I want to focus over the last decade, especially since the ImageNet moment, which obviously all the U of T participants will recognize very closely. And that's because that is when AI actually truly came into the mainstream in one way. It started becoming more commonly known outside the research community as a technology that not only has potential but can also deliver on potential. So for many, many decades, amazing research had been done. Potential was seen, but it was never realized, and that changed in 2012. But even then, the infrastructure to actually build and deploy AI solutions was fairly lacking. If you go back a decade, that was the time of kind of the quote unquote big data trend. There was infrastructure that was being put up to capitalize on that trend. And a lot of those tools were certainly helpful in driving the AI revolution. But beyond kind of some of those tools, there wasn't a lot available if you wanted to go and build an AI application and deploy it. The use cases were fairly limited. And that's because it was a new technology. Not many users actually realized its true potential and power. So it was limited to internal use cases where companies had access to the technology and actually the use case to make use of AI technologies. And what that meant was, to be successful, you needed not only the ability, not only the capability, but also the ability to build and deploy AI solutions. So it was the early time frame. A lot of large corporations made headway. Research certainly continued. A number of startups were born, but it was still kind of the beginning of this journey. And it essentially meant that anyone who wanted to build a solution was adopting this full stack AI solution, which meant that you're building the core infrastructure, you're building the application on top of it, and you were also kind of trying to really make it work for the use case out there. And in many cases, you were also kind of hunting for the use case to deploy this technology. And I'll talk more about each of these waves in the coming slides. This is more of an overview and a summary slide. The next wave I think of, which is the second half of the past decade, the last 5 years, is this emergence of this AI for X kind of category. What that meant is, from an infrastructure perspective, a number of ML tools were created. MLOps became a category. ML-specific hardware became available. And what that did was it enabled applications across industries and functions. So there were a number of tools available out there to build AI solutions, and a number of solutions for AI, solving AI for X, and you can replace X with any kind of category. So AI for healthcare, and then even within healthcare, you will have AI for radiology and AI for pathology and so on and so forth. And the key to success here was actually understanding the need, identifying the right AI solution. let me make sure I'm still on the slideshow mode. Oh, there you go. Understanding the need, identifying the right AI kind of tools, and then building the solution to make it all work. I think we are going to transition from that as we think about the future to something that I kind of call ambient AI. This is where AI utility, so akin to the hyperscalers and the cloud computing trend, will make it extremely easy for everyone to see and use AI solutions in pretty much every interaction that they have. You would have heard about kind of software eating the world over the last decade. If software is kind of eating the world, AI is going to eat software in the sense that it's going to be omnipresent in all of our software interactions. And to really make this successful, we'll look for broad education and deployment, as well as deploying it responsibly. And we'll talk more about what all of these things mean. Now, this is a very simplified caricature of what has happened in the commercialization of AI. There are obviously blurry timelines, but I've tried to put it in buckets just for sake of this conversation and to have some of the categories to actually go through. So let's go through these one by one. But keep in mind that a lot of tools that are developed in one kind of wave or phase of development actually mature over time, and then they enable the next wave to actually take hold. So with that, let's go back and talk about the first 5 years and the need for full stack AI. We'll start with kind of the market context here and understand what was the market context which led to this full stack AI solution being built. So the broader computer science kind of world really understood not just the potential, but also the ability of AI to make a difference after the ImageNet moment that I talked about a few minutes ago. However, if we look at what existed, you understood what AI could do, but it was still fairly limited. Image recognition was definitely a task where AI had excelled, but in addition to that, what else could be done was still a little bit of an unknown. And maybe the research community might actually have known, but if you look at corporations and enterprises and users out there, they certainly did not know exactly what are the art of the possible here. Talent was very, very limited to these groups of researchers who have been working on this for years, but these were scattered around the world in small research groups across universities, and it certainly wasn't the trend that it is right now. And as I mentioned before, there weren't any tools to make it possible to build these AI solutions. So what that led to is you require this full stack of actually understanding what the AI, what AI can do, having the talent to actually build something, and not just build the application, but also build the infrastructure to actually achieve the full potential. Now, there were very few organizations out there who could do it. Certainly the larger ones, the Googles and the Amazons and the Baidus and Meta, which was Facebook back then, had the requisite capabilities to actually achieve this. And beyond that, there were certainly startups that were created to harness this trend, but they had, I would call, moderate success. And you could see certain characteristics of all these startups that were out there. They were mostly founded by AI researchers because that is the world that was limited to understanding the power of AI. They were building the infrastructure as well as the applications from scratch. They're spending a lot of time educating the customer, and this is I'm not talking about the AI research community here. I'm talking about educating the customer in the sense of an enterprise trying to adopt your solution. You're spending a lot of time educating the customer, and as a result, because you had to fight so many battles, a lot of these startups, again, not all, but a lot of them, struggle to gain meaningful traction. And in many cases, these large organizations like the Googles and the Facebooks of the world who had realized the potential of these tools ended up acquiring these startups primarily for the talent or maybe some of the tools that they had built. So that is very, very quick summary of what happened in the first 5 years. However, a number of breakthroughs did happen, and that involved certain internal projects at the large organizations like Google and Facebook and so on to build these tools. There were certainly research organizations that continued building these tools, and there were some startups that actually made a name for themselves. So DeepMind is a classic example of a startup from this era, built by researchers, did a lot of work to build their own tools. The whole AlphaGo moment was, while it happened post the Google acquisition, it was focused on actually showing the world what is the power of reinforcement learning, right? So it commercially, that tool in and of itself did not have a whole lot of value, but it was about showcasing the potential and the power of the technologies that they were working on. But as I just mentioned, they were acquired by Google because it was a very rare group of talent, and Google wanted to have access to that talent in-house. So now we talk about the last 5 years, from 2017 to now, and how the AI infrastructure tools that were built and in some of these research labs and large organizations enabled a number of applications. So corporations at large started realizing the power of AI as they started seeing, again, the Googles and the Facebooks of the world kind of leapfrog and move further ahead. Those capabilities started fascinating these second movers or fast followers, and they started kickstarting a number of AI initiatives. But again, some of the fundamental problems, at least at the start of this kind of wave, still remain. So the talent pool was increasing, many more students, and a large part of the audience here is testament to that. We're starting to actually pursue graduate studies in machine learning and deep learning. So the talent pool was increasing, but it was nowhere close to the demand. I think even today we can see that the demand for this talent is significantly higher than the availability. And then a number of these tools started being spun out as either open source tools or as startups. So obviously TensorFlow and PyTorch are great examples. But even if you look at something like Snorkel, which started as, or Databricks, these are all research-driven tools that are now massive companies and startups out there. And while these software infrastructure tools were coming out in the market, there were a number of hardware startups that were also emerging. Certainly, you had NVIDIA spend a lot of time and effort making sure that not just their GPUs were enabling this revolution, but also building the associated infrastructure around it and the frameworks around it to make it easy for everyone to train their models. And then you have a whole wave of AI chip startups out there building chips for everything from training and inference. And what that meant was a number of applied AI startups started emerging, right? So a number of these early in-house projects from these large Fortune 500 corporations were unsuccessful because they did not have access to the talent, or maybe they hired a couple of people and they thought that was enough to actually make it work. They still lacked the education. But at the same time, there was a desire by the executive team or by other stakeholders to make it work. So when you had a startup that had the domain knowledge and that could take some of these tools that were out there and actually build a solution that worked in a real world setting, many large organizations would start using them. MLOps became a thing. A number of point solutions, everything from managing model versions to understand data observability to for feature stores, et cetera, et cetera. So there's a myriad of startups out there solving the problem of building ML solutions. And then I talked about the application-specific chips. As we go through these different waves, I'm going to actually pull a few examples of startups that I know well, which are in most cases examples of startups that are part of the Radical portfolio, and use them as case studies to illustrate some of these some of these trends. So the first one I'm going to talk about is a startup actually based out of here in Toronto called Untether AI, started by Martin Snellgrove, former professor at U of T and Carleton. They've built inference-specific chips, and their focus is building the most power-efficient inference-specific chips out there. The first generation of chips is already out there. That's the one on the top right. You can actually go and buy those chips right now. The second generation is being launched really soon. It'll be available early next year. And their focus, as I said, is building these chips that can run inference workloads at very, very low power consumption. And the reason why this is useful is if you start looking at what are all the solutions that could be powered by AI applications, the first one that obviously comes to mind is image processing and image recognition. If you want to use a lot of those applications on the edge in environments where you don't have the ability to connect to a massive power source, then you do want these chips that have inference capabilities with very low power consumption and latency to actually run those workloads. So think about a use case of using an algorithm to manage quality issues in a manufacturing line. So this is a manufacturing line, say it's manufacturing printed circuit boards, and you want to use cameras to make sure that the PCBs coming out of the line are actually perfect and there are no issues. You don't want to stop the line to process, to take an image, cloud, process it, and then kind of make a decision. These are things that you especially if the line's running at a really high speed, you want to do it at the edge. And that's where Untether and the chips that they are building can really help you. So this is an example of a hardware startup that's solving some of these fundamental infrastructure issues. This is an example of an application startup, again, a radical portfolio company called Covariant that is building solutions using a number of these tools that are available. So Covariant basically makes it possible for robots to be automated primarily in warehouse applications. So you see a number of these applications in the images on the right-hand side, everything from order picking to induction to put wall. And all of us, or most of us, I'm guessing, would have ordered something from Amazon or Walmart that shows up at our home. And as hundreds of thousands of us order these goods at the same time, these warehouses become more and more and more automated. In addition to being automated through kind of conveyor belts, there are some parts of this automation that has been fairly tricky. So if you think about what's happening on the top right image, you have a box that needs to be put into a shipping parcel. You might have a bottle, and the bottle can be a large shampoo bottle. It can be a bottle of a small, say, nail polish. It can be a t-shirt, a bag that holds a t-shirt that needs to be kind of put into a shipping box. And there's a wide variety of these different objects that need to be picked and put into shipping boxes. This is obviously something that human hands can do amazingly well. So to build an AI system to do it is a pretty daunting task, but Covariant has done it amazingly well. And they are obviously by no means the only one targeting kind of this AI for warehouse automation category, but they are one of the leaders out there. And they have used a number of these research breakthroughs to make these tools in a way that you can go from order picking to then an induction robot and then a put wall robot, even though technically they are doing different things, which is in one case, you're taking something off a conveyor belt and putting it in boxes. In another case, you have something coming off one conveyor belt where big pallets are being emptied and you're putting it in another conveyor belt or in bins. There is a lot of similarity that you can see across those three visuals. And that is where Covariant's technology really helps scale across these different automation use cases. So this is an example of an AI for X startup coming up in the last 5 years based on a number of these breakthroughs that exist there. These two were just two of the many startups that are out there. So I've taken an image here from September 2021. So Matt Turk has created this kind of AI landscape. He usually updates this once a year, and this is his landscape from last year. So obviously there are many, many more companies out there solving some of these challenges. And the goal of this image is not for you to actually read the different labels or the logos. It's impossible to do it. And that is actually why I put it here. There are hundreds of startups out there building kind of tools to build ML solutions. And then there are startups out there building solutions to solve problems in a particular industry or function. And the reason why this kind of chart is also important is if you exclude the boxes, I don't know if you can see, if you exclude the two boxes on the right-hand column, pretty much every other logo out there is a startup that is more of a platform startup or a horizontal kind of platform play. So you can see here that there are hundreds of these startups that have made it possible for others to build applications. And then the number of logos that you see on the right-hand side, if you can actually read some of the headings here, they go from everything from sales and legal and real estate and education to life sciences and transportation and agriculture, meaning that all the other solutions, that all the other ML ops tools that are out there enable all these applications. And by the way, this chart, being in the industry, I know this is not exhaustive in any way, shape, or form. From an applications perspective, you started kind of listing down all the startups that are solving AI applications. There are literally thousands of them out there. Now, obviously, as we go from here to the next wave, a number of these tools that are built here will enable the next wave. And what does the next wave look like? And I previewed it a little bit before. I call it the ambient AI wave, right? So this is where AI use cases and AI interaction becomes very, very common in all of our interactions. So what does this ambient AI experience kind of feel like? This is AI is integrated into your workflow. It is intuitive to use, and it improves your productivity. So what does this mean? I want to take an example, which again, many of us won't be familiar with, just to showcase what this experience looks like. And one example that comes to mind is Google Photos. I'd say Google Photos obviously does a great job of backing up your photographs and storing it on the cloud. So in case you need access to it and you delete it on your phone, you can do it from anywhere. But it also has amazing AI capabilities that power search on Google Photos. So this happens to me a lot, which is I'm thinking of something and I'm like, hey, do you remember this time when we saw X thing, but I don't remember which date the photograph was taken on? I can just search for it, right? So and this is a random example that I kind of put in there. It's like a red cycle in Amsterdam. And if you really squint your eyes, you'll be able to see that there's a tiny red cycle here. And this is taken in Amsterdam that exists in the history. And I don't need to remember the date it was taken on, exactly what the location was. I can just kind of Google and I put this in Google Photos and find it. So this is a great example of combining image recognition with the GPS data to actually find me something that I want. And in an interface, it's integrated into Google Photos. The other problem was me scrolling through hundreds of photos to find this image, and now I don't need to do that. And it's extremely intuitive to use, right? It's basic kind of text search, similar to Googling something on the web for something. Another example is if I search for civil rights, obviously all the images on the top there are from the National Civil Rights Museum in Memphis. So that's all from the GPS data. But there's an image at the bottom. Again, you won't be able to read it, but it's actually a board which talks about kind of living a life focusing on civil rights, and that's from Birmingham. And this is where it's again taking data not just from the GPS data, but it's also kind of recognizing the text and image, and it's surfacing this. Now, you might remember, you might have taken a photograph of a menu at a favorite restaurant, but you might forget which restaurant it was, and you might search for the dish, and Google Photos might kind of show that image to you, or you might remember that this is a photograph of your dog when the dog was playing with a red ball, and you can search that. And actually, Google does an amazing job of actually identifying pets also in addition to humans. So you can use this functionality in many, many different ways. And this is and the reason why I kind of bring this example up is this is a feature that a lot of us use, but in many cases, we might not even think about all the amazing AI that's working in the background to actually make it possible. And that is what makes this ambient AI. It just exists, it works, and it makes our life better. Some other examples that you might also be familiar with are autocomplete in again, Gmail and Google Docs and so on. It's starting to get better and better when you're typing an email and it starts to finish your sentence. The GitHub Copilot obviously has been around for a few quarters now and is making a lot of programmers extremely productive. So if these tools exist and we're already using them, then why do I say that this is a wave that's kind of starting to take off in the future, and why not now? And the reason I say this is these are, while they're illustrative examples, they are a limited number of examples. If I open up, if I am a sales executive and I open up Salesforce, my experience interacting with Salesforce is not the same as my experience interacting with Google Photos. Or if I am on a factory shop floor and I'm interacting with the software used to manage, say, a CNC machine, the experience is not the same, right? So while some of these tools have brought the AI kind of capabilities to the forefront, most of the tools that we use today really don't have that capability. And what is really needed is to actually have the equivalent of what the hyperscalers did for the cloud computing world for the AI world, right? And I call them AI utilities. And what will these AI utilities look like? I think we have some indication of what they would look like based on our experience with the hyperscalers. They'll have what I call kind of a low floor and high ceiling. What does this mean? It's very easy to get onto it, but the ability, there's an ability to actually kind of extract a lot of value out of it beyond kind of the basic use case, right? So foundational models are amazing examples where if you have a foundational model, and we'll talk about an illustrative example in a few seconds, is an example of something that just works out of the box, but then you have the ability to fine tune it and customize it to your use case. That is what kind of gives it the high ceiling, right? So it's something that works out of the box, but it also has a high ceiling on top of it. The next capability that I talk about is it should be as easy to integrate. The reason why I call them a utility is it should be as simple as turning on your tap or switching on the light bulb. Very easy to use and very easy to integrate into your workflows. Now, this doesn't mean that you are everyone and anyone and everyone will be able to use these tools. You still need electricians to wire your house, right? To take use of the electricity, but you don't need a number of electrical engineers to do it right now. And I think we are transitioning from that previous phase to the new phase in AI right now, right? Right now, if I need to use a number of these tools, if I need to build Google Photos today, I need a number of machine learning engineers to help me kind of achieve the same level of functionality. A software developer himself or herself who might know just maybe some backend and some front end can't kind of pull it together. But a software developer can certainly start using cloud services on their own. So I think that is where we need these AI utilities to go, that they should be extremely easy for a software developer to use. And maybe in a few years, as easy for just a tech savvy person to use also. And they should make it possible to use AI solutions everywhere, not just on certain use cases in certain domains. You should be able to use them via an API query, whether it's through a web app, or should be easy to deploy it on the edge too, right? So I think there's some work to be done for these AI utilities. Again, I'm going to use a couple of examples from our portfolio of companies that I think are building these capabilities. And one of them is this company called Cohere, again, a Toronto-based company building world-leading solutions and making it really possible for anyone and everyone to use this power of transformers-driven kind of foundational models. Started by a few folks that some of you might know well. Aidan was one of the co-authors on the original kind of transformers paper. Right now, they have a couple of products out there. There's a classification product, there's a generation product, but you can also combine the two and say enable a human-like customer support experience. Right? So right now, in most chatbot use cases, it is actually a really terrible user experience for many customers. In many cases, I get frustrated when I'm dealing with chatbot. The chatbot doesn't understand what I want. It will also not transfer me to the human on the other end, and I'm kind of struggling to parse out the menu there. If I can type in plain English and the chatbot understands what I'm saying and then can interact back in human language with me, it'll be an amazing user experience for me. And Cohere enables this. There's a meme that's been going around recently, and that kind of encapsulates this transition that we are seeing from the previous wave to this AI utility wave. So this is not my image. This is pulled off the internet. But the idea is you can just use Cohere and make it extremely easy to build these amazing experiences in a software, or you can use a number of these tools out there and spend a lot of time and effort trying to get something that's comparable. Another portfolio company, 12 Labs. To put it simply, they're basically building kind of Control F for video. So this is, if you want to search within a video, historically, you would either have to kind of watch it manually and really understand what's going on. You can take a transcript and search through that, or you can kind of put a number of tags on it. But they've built multimodal models which make it possible to just search an image, just like I did on Google Photos. I can search an image or search a video, sorry, to say, Mr. Beast eating a burger or whatever, and it'll tell me exactly where it is happening. Now, so far, I've spent a lot of time talking about ambient AI in the realm of kind of user experiences, and in many cases, kind of consumer experiences, and in some enterprise use cases. But it will also enable a new way of doing things, and this is where the quote unquote innovation will drive kind of the revolution, right? So if you think about drug and material discovery, historically, is based on the traditional approach was someone who spent a number of years understanding how a particular drug binds to a particular target. They'll spend a lot of time kind of running experiments and then spin out a business or maybe put out a new product out there. And that's how most biotech companies were formed in the last number of years. Recently, something different has started happening, right? So we have these AI tools that make it possible for you to search through the entire space of molecules and identify the right molecules that will be perfect for binding with this target, and do it all in silico and maybe iterate on it completely in silico. We have a portfolio company called Genesis Therapeutics that does this. They made amazing progress on a number of cancer drugs. However, this is still, if you look at amazing talent on the machine learning side, amazing talent on the medicinal chemist side, trying to kind of make it happen. But it's still not quote unquote ambient. And the reason I say that is that right now, most pharma companies still do things the old school way. If we completely reimagine a new world where AI just becomes another tool, where you don't think of Genesis Therapeutics as an AI biotech company, but any biotech company will be using AI to actually solve their problems. That is what I think AI will enable. It's not there yet for biopharma yet. I think like it is for, say, text generation, or in some cases, image recognition. Think about AlphaFold, right? So AlphaFold, if you have access to all of that data, you can start using that information and start designing new molecules in a way that you could not have done before. If you have access to a completely automated wet lab to run your experiments, not only can you design molecules, but you can kind of pass it on to a wet lab to actually run these experiments in real life. And then if you can expedite clinical trials, everything from, and there are companies trying to do this, but if you can, everything from enrollment to analysis of the data in a very automated way, you can significantly reduce the amount of time it takes to bring a new drug to the market. We have a portfolio company called Unlearn, and that's building one of these quote unquote utilities for the biopharma space. What they're doing is making it extremely easy to run clinical trials, use a combination of smaller clinical trials, but still with the same efficacy because of the way they build these models that can generate synthetic data to drive new information, which is relevant from a clinical trial perspective, but you don't actually need to have all of those people enrolled in a trial. So you can run a trial with fewer people enrolled and still get the same results and the same efficacy from those results. As we think about AI being used across a number of these tools and basically everywhere, I think the need for responsible AI research and tools to solve these problems will only increase. I want to, again, I'm not kind of picking on Google here, but because I was kind of running through those Google Photos searches, I actually found a couple of issues with Google Photos that really showcases the issues that a number of other researchers have highlighted around using AI. So the issue of bias. My wife is actually a professor at U of T, and some of her work involves archival photo work. So these are some of the archival kind of photos that she sometimes kind of takes images of just to keep everything kind of straight in her work. And as you can see, Google Photos has identified this one person and saying, hey, add a name. Now, it's interesting that Google Photos can identify this person of a photo which is a photo of a photo. That's great. But then there are some issues with it. So clearly this person in the middle row is the person in the middle row. But if you look at, again, the image might not be completely clear for you, but the image in the middle of the bottom row is actually an image of a statue. It's not this person at all. It's a statue. And Google saying it's the same person. And the bottom right image is actually a completely different person. It's he was a former Indian freedom fighter, and not this person at all, right? But you can see here that Google's kind of mistakenly assuming this person is the same as the other person. Now, maybe it is because these images are black and white. Maybe it is because the system actually has bias because these are South Asian faces. I don't know, but this is definitely a problem that needs to be solved. Another, and again, not picking on Google here, but this is an image that I saved from a couple of years ago. I was playing around with, I just installed Gboard, the Google kind of keyboard. And as you know, I work at Radical Ventures. I was filling out an online form. I typed Radical as I started typing Radical Ventures in the field when it asked for what company I worked for. And you can see the next word that's suggested there. Clearly extremely problematic. But this is before the keyboard learned that I worked at Radical Ventures. And you can see kind of out of the box what it is suggesting as the next word for radical. Again, an issue that certainly needs to be fixed. This happened a couple of years ago. I'm guessing they would have fixed it by now. The other issue is kind of all the harm that can come from putting these systems out there. So certainly there is, you would have seen a lot of news around generative AI in the last few months. Certainly with deepfakes and misinformation, that's a big issue. Here I'm going to highlight an issue around privacy, right? So the bottom images are actually my images. I've kind of grayed out the other people in the image, but you can see that there is a person behind me. And these are images from, I was sitting in a restaurant in Tennessee. Google has identified that person in those three images. That makes sense. But then the image on the middle row there is actually a 30-second video clip from when I was in London and the Pride Parade was there and I attended the parade. And now this has a number of implications. Either Google correctly identified this person in that video. In that case, there is an invasion of the privacy of this person who happened to be sitting behind me in Tennessee and now also happened to be in London at the same time at the Pride Parade. And exactly I know where this person was at both times. Or it incorrectly identified the person in the video, and then we go back to kind of the bias issue. So a number of different issues to be solved as AI becomes kind of omnipresent. So just to recap some of the last few slides, I think the next wave of commercialization is focused on on Ambient AI, where we use these experiences that are intuitive to use, that make our lives better everywhere, and that are powered by AI. But we need to build better AI utilities that can solve all sorts of use cases. Right now, we don't have AI utilities that can power something like a Covariant, right? Covariant is building a lot of their tools themselves. But tomorrow, if I imagine building a new robotics company, can I use some off-the-shelf tools to really make it easy to build a smart robot? I hope so. Obviously, a lot of work being done in multimodal models, starting with text to image and now text to video. Hopefully, that'll only get better. Deploying it in different paradigms, talking about kind of the edge use cases and so on and so forth. I think we need to certainly work on that, and enabling ease of use. So Cohere is improving their API endpoint. And if you've seen their API over the last few quarters, you would have seen that it makes it much easier to now use their API than it was before. I think you also need to really reimagine products and businesses. And this comes from unlocking really interesting use cases from the experience that a user has in their domain, educating a software developer to integrate AI into their products, and then as a business leader, really reimagining what your business can be. So think of all these text-to-image tools that are out there, whether it's Midjourney or Stable Diffusion or DALL-E 2 or whatever. If you are Photoshop or Figma or Canva builder, you really want to, as a software developer, integrate these tools into your product. But there are two different things you can do. One is you can say, hey, let's build Stable Diffusion 2, where it can come up with the next Monet or DALL-E painting that it generates looks amazingly like a Monet or a DALL-E painting. Sure, you can spend a lot of time doing that, but the reality is a Photoshop user is in many cases just trying to kind of match their color palette to the new corporate color palette and change a few images based on that. So integrating the tool in the appropriate way is probably the right kind of time that the software developer and the user need to spend in building their product. And then as a business user, now all of these things have happened. So if I own a design agency, and before I used to spend a lot of money charging my clients to just recreate all of these images for them every time they go through a corporate kind of color palette overhaul, how do I reimagine my business where maybe I go with and I'm making this up, I will make sure that your brand is always fresh. I will not charge you based on the number of hours that I've worked on your account. I will use whatever tools that are available for me, but I will always make sure that I will be strategic in how the brand should look and keep your brand fresh and pay me a retainer for it rather than a fee for service kind of model. So you need to do that as a business leader. And then focus on AI ethics, and that involves AI safety research, building technical solutions for many of these problems, and for a lot of problems still need to be regulated, but being forward thinking about it rather than being regressive about it. So those are, I think, all the challenges as well as opportunities that come about because of this next wave. For a number of you who are thinking about being a founder yourself, we are running a series right now. I was calling it the AI Founders Masterclass. You can sign up for it. It's tinyurl.com/AI Founders 2022. We're already midway through it, but if you join the program, you'll get access to the recordings from before. And obviously, if you have any thoughts on what I've presented, if you agree, disagree, feel free to email me. I'm available on LinkedIn as well as Twitter. And you can, if you're obviously building something in this world, in this AI kind of domain, that's an area that I invest in. So feel free to reach out for that. With that, I know I said I'll do 30 minutes of talking. I've done a lot more of that. I'll turn it back to Arvind for Q&A.
Thanks, Parasvil. You'd be great as a professor. We never stick to the allocated time we're given. Okay, so thank you very much for that talk. And I know that we're running a little bit late, but we do have time for a few questions. So please put your question in the Q&A at the bottom of your screen for Parasvil, or If you really want to ask in person, you're welcome to raise your hand and I will call on you. So go ahead and put in your questions.
Either
Parasvil,
I did an
maybe
amazing job or
you
no
did
one
a great,
understood anything I said.
you scared all the students. Can you talk a little bit more about you know, how Radical Ventures chooses, you know, some of the students are interested in being part of Radical Ventures. How do you choose?
Yeah, so I think there are three ways to quote unquote work with us. One is obviously if you're building a startup, we'll work with you to figure out if it's the right business for us to invest in. And there's a whole set of criteria that I can go in on how we decide to invest. It's primarily focused on backing amazing teams that are going after really large problems that can be solved with AI. So that's essentially the thesis. The second is working with our portfolio companies. Our companies are all AI companies. They need talent that has expertise in AI and machine learning. I can connect you with the right companies depending on your expertise as well as their expertise. And then occasionally we hire for our teams. And that again depends on, we have two teams. We have internally, there's an investment team and there's a velocity team, which is a team that works with our portfolio companies and helps them on a number of functional topics, everything from recruiting talent, thinking to go-to-market strategies, etc. Depending on what you're interested in, again, different set of criteria, but it's a fairly small team. So we recruit maybe a few people a year on that. If you're really wanting to work on AI, I think joining one of our portfolio companies or starting something on your own are the two kind of most common paths to work with us.
There's one question in the chat asking if the current AI downturn is affecting how you do things.
So it's actually, it's very interesting. And this is, if you've been following kind of so obviously the news around, there's a tech downturn for sure. There's a broad economic downturn. Within that, the tech stocks have been hammered for sure. That does affect the valuations in the market. This is broadly. But then if you've been following the whole, the fundings that have been announced for the last few weeks, and a number of these Twitter memes and jokes that are going out there, you would have seen that actually a number of VCs are pivoting from whatever else they were doing, whether it's the crypto or the metaverse or whatever, to AI right now. And we internally kind of chuckle about it, that we were kind of the OGs in the space, and we continue to, we believed in it before, and we continue to believe in it. So it's, I think right now, others are starting to see the potential. So we see that there will certainly be increased competition, but at the same time, I think from an AI perspective, it's going to be better because there'll be more capital available. Someone asked for, so my email is just my first name at radical.vc, Parasvil @radical.vc. So that's an easy one to answer. The next one, are there AI products that deliver to individual customers? So I would say yes and no in two ways. In the sense that if you are an AI utility, then in many cases, it makes sense for enterprises to use your product, right? Like an individual user will not go on AWS and spin up a cloud server. I mean, you could spin up an S3 bucket to store your photographs, but it's just much easier to use Google Photos. Similarly, today you can actually use some of these models to play around with it, right? So there are a lot of people, again on Twitter and LinkedIn, etc., putting images they've created by interacting with Midjourney or Stable Diffusion, etc. But that's not a real use case. That's fun and that's a little bit interesting and entertaining. However, the companies that will build products using these tools will for sure be interactive. Also, and we do this as a thought process all the time. It's like literally name any software product that you interact with as a customer. It either has some kind of AI capabilities built in, and if not, we can kind of think through 5 to 10 of those capabilities that you can kind of add to it and make the user experience better. I know we are at time. Arvind, do we have a few more minutes to go through other questions, or should we cut it short?
Yeah, absolutely. Let's take 2 or 3 more minutes.
Sure. About predict companies like, the question is, what do you predict companies like Google would bring about ethics to personal data like photos? Would it get better or worse? And government, and how will government bodies respond? So I think the whole privacy concern is something that is going to be both regulated as well as kind of I think solved is too big of a term to be using here, but in some ways addressed by technical tools, right? So privacy is an area where you can give the user the control of what they want to do. Now it gets tricky for companies like Google, whose entire business model is built on advertising, to give you complete control on all of your personal data. Because if you do that and you say, I don't want any ads and I want all my data to be private, then you are, like, as a user, not really relevant to Google. But at the same time, you can still build relevant kind of badges to make sure that if your data is being used to create the next kind of Imogen, and someone goes and searches and says, hey, create Parasvil who looks like a devil, like it'll not have my likeness, it'll not create it or whatever, right? And at the same time, government will for sure be regulating these tools. And on privacy, we've already seen these regulations, right? GDPR, CCPR are examples of these privacy regulations, but certainly they need to be improved as technology changes. As we've seen with regulation, my guess is it'll take time to catch up. Sometimes it'll be an overreach, but eventually kind of the pendulum will swing left and right and kind of will settle in the right direction. The next one's, how do you suggest academic researchers with strong technical skills identify an application use case? And then the guess is that the best use cases are industry and business specific and not obvious. So that's a great question. And I think as startup founders, a lot of times startup founders solve the problems that they face, right? So if you are an academic researcher, you run into issues, and which is why a lot of these MLOps tools have been created by founders or have spun out of research organizations and universities around the world, because they had the problem of building these AI solutions. They didn't have any kind of frameworks to build it. They kind of build the tools and then they spun it out and created business on it. So if you run into problems yourself, it's possible others are running into the same problem, you can solve it. The second is, in many cases, you will go and work in an organization after, say, the MSc program here, or during the MSc program, where you work in an organization and for a few months you see that everyone's struggling with this problem and you've experienced it firsthand, or you hear a lot of people kind of saying the same thing and really understand that market need, or you get a co-founder who has domain expertise in a particular industry or function, and you can leverage their expertise in that industry to drive the product vision, and you kind of solve the technical part of the challenge there. And even after doing all of this is the first kind of idea that you will have. As founders, you always need to keep an ear to the ground and hear what the market is saying and what the feedback you're getting from the market on your product, and create your product based on that. So that's a skill that you will have to develop anyway. But for the initial idea, I think either you run into the problem yourself, you hear about the problem from someone else, or you have a co-founder who has faced the problem and is coming with domain expertise.